Good morning. My name is Thanakit Linkam. Today I will present you heavy metal adsorption by biochar made from longan seed and peel. Let's start in introduction. Biochar is a product from agricultural or waste or organic waste via slow pyrolysis. At the proper atmosphere and temperature, it can be mixed with the soil to improve cultivation. The heavy metals such as arsenic, cadmium, or lead are dangerous chemicals. They are generally contaminated in the soil from industry or remaining facility. Soil in the residue or agricultural area are contaminated with heavy metal will be devisely affect to the health of those who receive it to accumulate in the body. This study aims to study the capacity heavy metal absorption by the biochar derived from longan residue. Material and method. The real material is a longan residue from seed and peel. Both materials were subject to pyrolysis at 300 Celsius for 4 hours with a heat rate of 5 Celsius per minute and dry it in a hot air oven at 105 Celsius for 24 hours and get it to determine pH and EC. The heavy metals are solution of single blend fertilizer mixed with DI water. In the adsorption experiment, we used 0.4 gram of biochar was mixed with 100 ml of heavy metal solution. The solution was checked at a speed of 200 rpm for 0.5, 1, 2, 4, 6, 8, 12, and 24 hours and was filtered. The concentration of arsenic and lead was determined by XRF. And result and discussion. The table 1 shows the BLP appeared to contact more remnant than the BLS. In addition, the pH and EC value of the BLS were 7.92 and 344.57 micron respectively, which were smaller than those of the BLP. Arsenic and lead contained in the fertilizer before mixing with DI water has concentration of 26.33 ±5 ppm and 9 ±5 ppm respectively. After mixing, the solution was tested of the trace element with XRF. So, the concentration of arsenic and lead were 16.83 ±3.5 ppm and 5.92 ±4.33 ppm respectively. In the composition of trace element detect in a BLP before and after check in a figure 2I. BLP had additional elements of titanium, iron, arsenic, rubidium, sodium, and lead. The highest element is iron, which had a concentration of 5,993.96 plus minus 122.68 ppm. And comparison of tag element detected in a BLS before and after shake in a figure 3I. The compound is in a BLS after shake was titanium, iron, arsenic, sodium, and lead, and the highest element is iron, which had a concentration of 2,120 plus minus 18.75 ppm. And the surface of the biochar was predominantly detect negatively ionized with the adsorb positively ionized element such as iron, cadmium, or titanium. The biochar adsorbent solution or element until structure and don't able to adsorb element equally. In a figure 4a, show a arsenic contact after shake at 0.5 to 24 hours, and in a figure 4b, show lead contact after shaking to 0.5 to 24 hours. In the figure 5a, show arsenic contact after shaking at 0.5 to 24 hours, and in figure 5b, show the lead contact after shaking at 0.5 to 24 hours. In the biochar could absorb both arsenic and lead depending on the number of the track element. When detective biochar electron bound to the element another than arsenic and lead, it could have a low number for negative electron on the surface in the biochar, resulting in the higher almost of the arsenic and lead less water capture at a different time. Conclusion: in these experiments, the biochar derived from longan peel and longan seeds was tested for the absorption of the arsenic and lead. The BLP was for absorb more arsenic and lead than the BLS. The BLP can absorb significant amounts of arsenic was 14.33 plus minus 3 ppm at shaking time of 0.5 to 2 hours, and 6.8 plus minus 4.23 ppm at 4 to 24 hours, while the BLS adsorbent a smaller most of arsenic was 4.78 plus minus 3.56 ppm. The lead absorption of the BPL at a shaking time of 0.5 to 24 hours was 4.48 plus minus 3.27 ppm, washed with higher than the BLS was 1.63 plus minus 1.25 ppm for the same period. And thank you for watching.